This is the first of 2 recordings with how to find the distance on the coordinate plane. So basically how you find the distance between 2 points. Remember, if you take notes and put them in a spiral, you're welcome to use them on your assessment, which should be coming up in about 2 weeks. If you don't, well, bummer. So if you want to write down the procedure here and a couple examples, that's great. You might want to print off some graph paper or make sure you sketch it. Either way is fine. Okay, so the first technique we're going to do is just basically using the Pythagorean theorem. So we're going to go ahead and start that now. So defining the distance on a coordinate plane. Graph the 2 ordered pairs to connect the points and label the segment C. So the first thing you have to know is remember how to graph a point. So remember the first value is x, second value is y. So x tells you how far to the right or left we're going to go. Y tells you how far up or down you're going to go. All right. We're going to label it C, which is appropriate because that line you just made is going to be the hypotenuse of a right triangle. And then we're going to go ahead and just draw the legs of the triangle. There's a couple ways to do it. Then you're just going to simply visually count to find the length of those legs. And then after that, you're going to use the Pythagorean theorem to find the length of the hypotenuse C. That length is the distance between the 2 points on the coordinate plane. So fairly straightforward. And I think the hardest part for a lot of students is basically putting the points down and then counting. At this point, what I'm seeing in class, at least in my cohorts, is that most of you are pretty comfortable with using the Pythagorean theorem, especially when you're just trying to find the hypotenuse. So that's the easy part. The hard part is just basically setting it up. So we're going to do a couple examples of that now. So first one, watch it with me. And the second one, if you want to pause and try it on your own, by all means do so. All right, so first thing I'm going to do is put those points in the graph. So remember, 1 is my x. So quick reminder, we have x, y. 1 means I'm moving 1 to the right. 3 means I'm moving 1 up. So I'm going to go right 1 and 3 up. And I'm going to put my dot right there. Okay. The next one is at 4, -2, which means I'm going 4 right and down 2. So I'm going to go over 1, 2, 3, 4. Then I go down 2. Okay. Now I'm going to go ahead and insert a line and connect them. So I'm going to go from this point to that point. There we go. I'm going to make that line a little bit bigger if I can. Let's see if it's going to cooperate with me. I might have to grab it. Yeah, there we go. All right, let me zoom in on that. So we'll zoom back out when we're setting up the equation. Let me zoom in on the graph real quick. Okay, so there's my line that connects the points. This will be the hypotenuse. Now I want to go ahead and insert a new line in here. I'm just going to draw a new line that represents either the A or the B leg of my triangle. So I'm going to go ahead and make a line that goes down. There's my, I don't need it to be that big, so let me change that. Bad Mr. Robinson. Let me try that again with a line that's more reasonably sized. All right, so let's go ahead and do that now. So there's my one of my legs. Here's my other leg. All right, so now we have our 2 legs. Right angle, that's my hypotenuse. I'll label that C. Now we just count. So I'm going to go ahead and count the distance from here to there. So a mistake a lot of students will do when they're counting is they'll start by saying 1. Before I've moved my cursor, my pencil, whatever you're using, you can't say 1. You can't say 1 until you've moved 1. So what I like to do is make these like little camel hump things looking. So 1, 2, 3, 4, 5. So the length of the first leg is 5 units. I'm going to do the same thing with the other one. 1, 2, 3. The length of the second leg is 3 units. All right. Now I'm going to take that information. I'm going to plug it into the Pythagorean theorem. A squared plus b squared equals c squared. And I'm going to find what c is rounded to the nearest 10. So I'm going to go ahead and do that now. So 3 squared plus 5 squared equals c squared. So 3 squared is 9. 5 squared is 25. And we have c squared too, so let's go ahead and the sum of 9 and 25 is 34 equals c squared. I know that the square root of 34 is going to be slightly less than 6 because the square root of 36 is 6 and 34 is slightly less than 36. So, but you know, I have a calculator in front of me, so I'm going to go ahead and plug 34 in. And it is 5.83095. So if I have 5.83095 and I want to round to the nearest tenth, that means I look at the 100 right there. That is 5. That is less than 5, which means I'm just going to leave that as 8. So I can say C is approximately 5.8 units. So that means the length of the distance between the point 1, 3 and 4, negative 2 is approximately 5 and 8 tenths of a unit. Once again, after you have the points in the right spot, make a right triangle, solve for the hypotenuse. Okay. So here's the second one. If you want to try this on your own, I would encourage you to go ahead and pause the video, try it on your own, and see if you do it right with me here in a second. All right, so negative 2, negative 4, which means I'm going left 2, and down 4. And then for 3, 5, it means I'm going right 3, 3 to the right, and then 5 up. 3 to the right, 1, 2, 3, 5 up. Okay, now I'm going to go ahead and connect those. I'm going to go ahead and insert a line that connects the two of them. So here we go. Here's my line. And I'm going to go ahead and call that C. All right, let's go ahead and zoom in on that so we can do the rest of it with a little more precision. All right, there's my hypotenuse. It will be my hypotenuse at some point, and I'm going to go ahead and draw my line. So there's my height. Doesn't matter if you call that A or B, it doesn't really matter. And there's my other. So there's my two legs of my right triangle. My hypotenuse is over there as it should be. And now we just have to count. So remember, when you're counting, don't say 1 until you've moved your cursor, your pencil, whatever it is. So let's start at the right angle. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, for those really paying attention, and just think about this real quick, that y value here is 5. The y value here is negative 4. So what's 5 minus negative 4? Hopefully you're making a connection there. Okay, let's do that for our horizontal line here. So we have 1, 2, 3, 4, 5. Okay, so once again, I have a x value of 3 and a y value of negative 2. So my question for you is, what is the value of 3 minus negative 2? Curious. Oh, it's 5. That's right. Okay, let me zoom back out. Okay, let's go ahead and set up our Pythagorean theorem. So we have 9 squared plus 5 squared equals c squared. Like I said, I'm confident most of you are fine with this now. So 9 squared is 81. 5 squared is 25. The sum of 81 and 25 is 106. Okay, I know that c squared, that c is going to be slightly higher than 10 because the square root of 100 is 10 even. But I have my calculator, so I'm going to go ahead and plug the value in. So for the square root of 100, my calculator is giving me this value right here. Let's look at it. 295630, blah, blah, blah. It goes on forever. Okay, so I'm running to the 10th, so it means I need to look at the 100th spot. That is 5 or greater, which means I'm going to round the 2 up to a 3. So my final answer would be C, is approximately 10 3/10 of a unit. Okay, so that is determining the distance between 2 points using a right triangle on a coordinate plane. The next video will cover finding the distance using the distance formula. All right, thanks for watching. Bye.